Having covered the crypto map rules in depth and length, we're going to get to our configuration now. The only thing that I've already written is the ACL. I wrote this on R1 and R3, taking care, of course, to put a mirror image on and not an exact copy, and that's the last time I'm going to mention that for at least a few minutes. So let's bring router 1 up, and now we're going to start applying it and making that ACL into a crypto ACL, if you will, and we do that with the crypto map command. And we got to give it a name, so I'm just going to call it CCNA Security. And we got to give it something here as far as the sequence number goes. I'm just going to go with 100 here. So this makes it easy to edit a map later if you want to add something, just like ACL sequence numbers do. And now I'm going to go with IPsec ISAKMP. And that's actually going to be it. And we get a note, really a warning. This new crypto map will remain disabled, that means it's disabled now, until a peer and a valid access list have been configured. So you, the experienced network admin, will not panic when you see this. You've probably seen the thing with login and password on a router just when you're setting the console lines or the VTY lines. And I should say, and you've got 5 lines, of course, by default, 0 through 4. And if you put in login first before password, you get this message about, oh, this is invalid until password is entered. You get it 5 times, and the first time you see it, it can panic you a little bit. But after that, you just say, okay, just do the password and you'll be fine. Well, as long as you go ahead and set a peer and refer to a valid access list in your crypto map, it's going to be enabled. You're going to be fine. So how do we do that? We're going to do matches and sets here, and we're going to start with match. And you don't see any ACL value here, do you? There's only one match address, and this is actually the one we use. And here it's going to ask for the ACL number. So it's not match ACL or match list, it's match address. And also note that the theory that we cannot use standard ACLs for this operation is verified because you don't even see the standard numbers here. You only see the extended list, the 2 ranges, and of course we could have named it if we had wanted to. So we're going to go with match address 103, and we're going to do a couple of sets here. Set values for encryption decryption. And we've got a couple to choose from, I think about 7 or 8, yeah, 8 of them. And we're going to go with peer and transform set. That's what we need, because first off, we got to set that peer because the router told us we had to. That's our allowed encryption / decryption peer, and that is going to be 172.12.123.3. And we're also going to set the transform set, and we are going to just call CCNA because that's the only one we wrote. And if we had written multiple transform sets, you just put them in the order that you want them to try to be used, and just keep putting proposal tag, because that's actually what they are really. Transform sets are just proposals. We'll see that in some debugs when we actually put this baby into operation. So we've got our set peer, we have our set transform set, and we are good to go. Or are we? We're at the step people tend to forget. And it's the last step. So you don't want to leave this out, because if you leave this out, nothing's going to happen. We wrote the crypto map. We wrote the ACL. Then we wrote the crypto map that made that ACL into a crypto ACL, if you will. Now we have to apply it. And you do apply it to the interface in the exact same way, almost, that you would a regular ACL. You're going to use the crypto map command here. And let me use iOS Help here to illustrate to you that the only option here is the name. Always check these when you're troubleshooting, because it's really easy to leave a letter out, something like that. It's got to be exact. And what do we not expect to see here? We do not expect to see in and out, because we are CCNA Security certified, and we know the deal with the crypto map and the inbound and outbound rules. So the router's not even going to let us try to apply that inbound or outbound. It is just applied. And that is it. That's the config. You get a little message there, ISAKMP is on, so you're good to go there. It's a confirmation in this case, actually. You'll always see that after you apply the crypto map to an interface. So we wrote our crypto ACL, we wrote our crypto map, and then we applied the crypto map to the interface, 1, 2, 3. That's it. Now we're going to go on over to router 3. Let's just go over those commands one more time, because we've got the ACL over here already. Just want you to see them in action again. Then the number, and then you need IPsec ISACMP. And that's all we're going to do. We're not going to use those options. We'll save those for another day. We got our little message. So the first thing we're going to do is match on an IP address, because that's the only option we have there. And it's 103 on this side as well. I set the peer to 172.12.123.1. I set the transform set to CCNA. Ah, look at that. Transform set with tag CCNA does not exist. I love this. Now, this is the kind of thing that you're going to see on the live equipment that you will not see, say, on an exam question, that kind of thing. But I did leave the transform set off on purpose, and yes, that is my story, and I am sticking to it. Because I want you to see that when you're writing these, if you refer to a transform set that doesn't exist, it's going to tell you right here and there. Now, if you're showing a config on an exam, I don't think they're going to say, hey, by the way, you got this message on the router that the transform set doesn't exist. But that is something to look for when you're troubleshooting as well. So what I am going to do during the break is write the transform set, and it's going to match the one on router 1 exactly. I'm going to apply it to the interface. Those are the only two, and then I'll just apply this to the interface, and we will be ready to test and verify. We'll verify the config at the beginning of the next video, take a look at it on both sides, make sure everything's there we need, and then we're going to start testing our VPN and debugging as well. I'll see you there.